Hello student, welcome back to lecture series on linear differential equation with a constant coefficient. Within that already I started topic symmetrical simultaneous differential equation, which is the last topic for this chapter. I already uploaded plenty of the videos based on these topics. In my previous part I explained to you all method of combination or grouping method for solving symmetrical simultaneous differential equation. Okay, so in our today's lecture I'm going to explain to you all which is the solving it is a useful method of a multipliers, okay, which is a useful for solving symmetrical simultaneous differential equation. Okay, that method already I explained in my previous lecture, so if you are interested to see this video, go and check in my playlist. So in my today's video I'm going to explain to you all one of the example which based on the method of multipliers. Okay, we are going to solve this example using method of multipliers. Okay, yes. So what method of multipliers do? We consider some multipliers. Okay, we consider some multipliers in order to substitute the values. Okay, yes. So first of all, always remember that consider the multipliers that can give us the easy answer. Don't go for the any difficult multipliers. Okay, so multipliers we usually consider L, M and N. Okay, I consider L1, M1 and N which is equal to 1. Okay, these three are the multipliers. Okay, take these three multipliers and multiply to our given symmetrical simultaneous differential equation. Okay, yes. So how I'm going to write dx by y minus z. Okay, dx by y minus z which is equal to dy by z minus x. Okay, which is equal to dz by x minus y. Now see that how I'm going to write this using multipliers. Okay, already I explained how to use this multiplier. We multiply that multipliers and add the numerator. Okay, so 1 into dx which is a dx plus 1 into dy L dx plus m dy plus n dz. It is like this. Okay, so 1 into dx plus 1 into dy plus 1 into dz, that means dx plus dy plus dz, and total divided by 1 into this term, 1 into this term and 1 into this term. Okay, this is the actual form of dx by p, dy by q and dz by r. Okay, this is the form of dx by p, dy by q, dz by r. Okay, yes. So what we do, multiply this and add them. Okay, so after multiplying 1, all terms remain same. Okay, so we left here with the value y minus z. Okay, y minus z plus z minus x plus x minus y. Okay, so try to cancel similar term, minus z plus z cancel, minus x. Okay, now let me see first of all the values. Minus x plus x and minus y plus y cancel. Now see that it represents that denominator, entire denominator gives us the value 0. Okay, if entire denominator gives us the value 0, what we do, we take numerator 0. Okay, now see that in our previous method how I explained. Okay, so if LP plus MQ plus NR, if it is goes to 0, then we take L dx plus M dy plus N dz which is equal to 0. Now obviously we see here we got the y minus z, entire denominator value gives us the 0. Then we write a dx plus dy plus dz which is a 0. Okay, we write a dx plus dy plus dz which is equal to 0. So if it is a 0, then take the integration. So we write integration of dx plus integration of a dy plus integration of a dz which is equal to 0. Okay, take an integration x plus y plus z which is equal to c1. This one is our given first function. Now see that guys, using method of multipliers I got the answer in a 2-step. Okay, only in a 2-step I found the answer. Okay, so as we have, which is a simultaneous differential equation. Okay, simultaneous symmetrical differential equation, that means it possesses two different solutions, c1 and c2. Okay, I'm going to solve another one here. Okay, so as I consider L1, M1 and En1, so consider L dash, M dash and n dash. Okay, L dash, M dash and n dash. Again consider three another variable. So L dash consider x, M dash consider y and n dash consider z. It is completely up to you all. Okay, anything you can consider, but consider that we have the differentiation in the form of x, y and z. Okay, yes. So what we do, replace and add. Okay, so dx, L dx plus L dash dx plus M dash dy plus N dash dz. That means x dx plus y dy plus z dz. Okay, so how I'm going to write x dx plus y dy plus z dz. Okay, I'm going to write x dx plus y dy plus z dz. Okay, and denominator similarly replace the term L dash p plus M dash q plus N dash r. Okay, as you done it before here in this method. Okay, you have to apply same here. So I'm going to write xp, that means x into y minus z, x into y minus z plus y into z minus x, y into z minus x plus z into x minus y, z into x minus y. Okay, this one I applied here. Okay, L dash a dx plus M dash dy plus N dash dz, which is equal to L dash p plus M dash q plus N dash r here. Okay, this is just the replacement of value. So as you're going to calculate the denominator, obviously you will get the denominator as a 0. Okay, so if denominator is 0, which gives us the x dx plus y dy plus z dz, which is also the 0. Okay, which also gives us the value 0. So dx dy dz there, then apply integration x dx plus integration of y dy plus integration of z dz, which is equal to 0. Okay, yes, apply integration for x, which is x square by 2 plus integration of y, which is y square by 2 plus integration of z square by 2, which is equal to c2. Take 2 to the other side, we write x square plus y square plus z square, which is equal to 2 times c2. Okay, so you consider only c2, as I told you already. 2 times c2 and c2 both behave similar here. Okay, now see that this one is f of xyz, which is equal to c1, and f of xyz, which is equal to c2. This one is our entire solution for our given simultaneous symmetrical simultaneous differential equation. Okay, now see that how easy it is. I just applied the method for multipliers. Okay, at the beginning I consider multiplier as 1 1 1, and for the last solution I consider multipliers as x, y and z, so that we can apply dx dy dz easily. Okay, so I hope you all have understood my entire solution. It is completely easy, guys. Don't have anything, just need to understand the method behind of this. Okay, I hope you all have understood entire my today's lecture. Even after, if you found anything difficult, confusing, guys, anything challenging, let me know in my comment section. I will come up with the similar videos. So thank you everyone, thank you for my today's lecture.